All right, hello everyone. Mr. MathWell here. We're going to talk about the sum difference rule. We've been talking about the differentiation rules in calculus, constant rule. We've talked about the power rule. Those are two basic ones. We're going to talk about the sum rule and the difference rule. Very, very easy, okay? It's simply this. If you have some kind of polynomial, we've been dealing only with single terms before with these other rules. So what happens if we have a polynomial? If we have terms added to one another, how do we find the derivative of that polynomial? No problem. We find the derivative of each individual term and add or subtract accordingly. It's super, super easy, okay? So if we just had f, right, and I wanted to find the derivative, that's the derivative. But if I have f plus g, and I want to find the derivative, okay, f plus g, I want to find the derivative, it is equal to simply adding the derivatives together. So the sum rule can be summed up as just add the derivatives of each of the terms that you see there. If you're taking the derivative of a big collection of terms, pretty easy. Whether it's two terms or three terms or 17 terms, doesn't matter. So here's some examples. I would know how to take the derivative of x squared, power rule, right? Derivative of 4x, power rule, no problem. The derivative of negative 50, constant rule, easy. The derivative of root x, power rule, like it's all. So if we want to find now f prime for a, f prime of x, I simply add up the derivatives of each term. So this becomes 2x plus 4, and you're done. Okay, that's the derivative. For e, all right, the derivative of this one, or this is h, I guess, whatever, h prime, the derivative is simply the derivatives of each of these terms, and because we have a minus here, we just subtract the derivatives. That is your difference rule. So this is actually x to the 1/2, which is probably a good idea to view it that way. So you take the derivative, you bring that 1/2 down in front, and you subtract 1/2 from, you subtract 1 from the 1/2 to get the derivative of the first term. And then you minus, and you have here 20x to the 3. Okay? So if you have let's say you had a negative exponent, okay? If you have a negative exponent, no problem, just minus, then bring the negative down so it turns into a plus. No big deal, just follow all the rules, okay? Now again, this negative exponent, your teacher might want you to write this with positive exponents and instead of fractional, maybe in roots. So this would be actually 1/2, and then this comes down to the denominator, x to the positive 1/2 down here, or root x. So you might see this in your textbook, or your teacher might like that better as a derivative. But that's the sum difference rule. Doesn't matter how many terms you have in your polynomial, as long as it's a polynomial of some sort, you can just add or subtract them. Let's do k, one last one. Let's do k. This one looks really strange, doesn't it? A, b, and c are constants, all right? So u prime of t here, the derivative of a is 0. It's a constant. Now what about this though? Oh goodness, b over t. All right. You know what you could do is you could actually rewrite this as a plus b t to the negative 1 plus c t to the negative 2. And that actually might be a better way to go, just to view it like this. So individual terms, and then you can use your power rule, right? So we got 0, we got plus. Now this negative 1 comes down. Remember I said that, just bring that negative down. Negative 1 times b times t to the negative 2. You subtract 1 always, so that becomes more negative. Plus negative 2c t to the negative 3. Okay. Forget about the 0. You don't have to write that down. This is negative b. Now this t to the negative 2 is over t to the positive 2, t squared. So you can write it like that. And then we have plus a negative. That's same as minus 2c over t cubed. You might want to factor a negative out because you definitely have a common factor there. So you could do this and your answer might look something like this. All right. So that's a bit of a tricky one, but it's still just the sum difference rule. I guess we were more practicing the power rule there, right? With when you have negatives, it looks a little funny. So that's the sum difference rule. Just add or subtract the derivatives, and if it's a combination of plus, sum, minus, difference, no problem. It's literally, I could write a third one. I'll do that real quick. I do that real quick. Plus g minus h, okay? No problem. It's f prime plus g prime minus h prime. That's the combination. Good to go? Easy. See ya.